Okay. Can everyone hear me?
Yes.
Hi, yes, I can hear you.
Hello? Hello?
Hello.
Hi, can you hear me?
Yes, I can.
Can everyone hear me?
Yes, we can hear you. Or I can.
Hello? Okay. Okay. Today we'll be talking about just a recap about data structures and error handling. So I know Zaid actually covered a lot when she did her tutorial. I'm going to be building on that. So we try to reflect on different data structures that we have, and how to handle errors, because most times we encounter a lot of bugs in our code, error messages. These are not actually it's not a bad thing. It's actually a good thing for us to know how to manage this, understand these errors, and make our programs running. So I'll be using okay. So I'll be presenting now. So I'll be presenting now. Can you guys see my screen?
Yes, I can.
Okay. Okay. Okay, please feel free to unmute, and let's try to make it interactive so we can flow better. Because I'm just like, so we can flow. If you have questions why I program, just let me know. So firstly, to start, I'll open my terminal. The terminal is just I'll open my terminal. And I'll just create I'll go to where I want to create the Jupyter notebook. I'll cd to it. The okay, make directory workshop ls cd into workshop. Cd into workshop. So can you see my Jupyter notebook?
Yes, I
Can you see
can.
my Jupyter notebook?
Yes. Can you hear
And
me?
how did you make it that green?
Hi, can you hear me?
Hello?
Can you
Can you
hear
see my
me?
Jupyter notebook?
It looks like you can't hear us. I don't know what's going on
Okay,
with that.
but you can hear me.
Yes, I can hear
Okay,
you.
perfect. So I think we just let him know that that he can't hear us.
Can you see my Jupyter notebook?
No, no, we can't see your Jupyter notebook. We're actually seeing
Wow.
the other screen you're presenting.
Here you go. Okay, let me use my headset. Hello?
Hello, can you hear us? Hello, can you hear us?
Hello?
Hello,
Okay. I can hear you guys.
can you hear us now?
Yeah, I can hear
Okay,
you now.
cool.
Okay. So can you see my Jupyter notebook now?
We can't see your screen yet.
Wow, wow, wow. Oh,
Your screen is not projected yet.
okay. I'm having a lot of technical issues right now. Trying to fix.
No stress.
Okay. Okay. Can you see it now?
Yes, we can. Can you? Can you?
Okay.
Well, yeah.
We can see your screen now.
Okay. So the initial step I did was to create a repository, like a folder to store my files because this is a very good skill you should get because when you're working on bigger projects, you actually want to handle your file, where you store files and all that. So it's good practice to actually create folders for your files. Okay, so first of all, I just
Are you
created.
are you going to show us again how you created the folder?
Okay, you didn't see it. Okay,
No,
I
no,
think
no,
then.
no.
Okay, okay. So what I did, I used my terminal. Can you see it here?
Yeah.
I open my terminal. Can you see my terminal?
Yes, we can. We can.
Okay, so let me just create another one. So yeah. So initially, it's when you open your terminal, you get your initial your desktop. If you can say, you see MacBook Pro, Code Brain. This is actually my desktop. So I do CD document ls to list the folders at my desktop. I can see desktop document download. So I want to go into my documents. I do CD documents. I'm inside my document. And you can see inside my document, I have application related, drone project, final inclusion. I have different project folders here. So I want to go into my workshop, simply workshop. Okay.
Okay, bro, we can't see your screen. We're rather seeing. Why are you typing something now?
You can see my screen. Oh,
Okay,
wow.
we just saw your screen now.
Wow. Okay. I think Google Meet not allow me to present outside the web page I am. The web. What I was doing was on my desktop. I think they have an issue there. So you can. Okay. So you just have to create. What I did, I just created a folder in my documents to actually save this file I want to work on. So rather than just open Jupyter Lab anywhere, I opened it in my the document, the folder I create. I want to save it. Okay, so just a quick guide to the story about and principles of Python, also known as the Zen of Python. Can you see my screen? So this is the Zen of Python.
Yeah.
Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. You can go through it. So, but one of these are just like the pillars and principles of Python. Python excels in readability, simplicity, and as you can see, there are so many underlying principles. So that's what makes Python unique. So today we'll be talking about data structures and error handling. So that's what we're talking about today. So from your previous class, I wanted you guys to engage me. What are the different data types we have in Python? Just a recap. Okay, let me give you a hint. We have int
Integers,
for integer.
float. I'm not sure if I'm right. Strings.
Yeah.
There's a fourth one missing. Yeah, I forgot.
The fourth one I think is booleans.
Yeah. Cool.
Yeah.
You guys are already Pythonistas. So we have this. An integer can simply be a equals to 5. A float, which indicates a floating point, that means the decimal. So we can something like this. 5.0. And the string one written with quotation marks, and a boolean either true or false. So if you check this type of A, we have int. Type of B, we have floats. Type of C, we have string. And type of D, we have boolean. So you might ask, what's the data structure? So data structure are just basically things that hold this data in place. So and in Python we have four data structure basically. Um, Types of data structure. We have one. We have list. Two tuples.
Hello, Brain,
Three.
your screen is off again.
My screen is off again.
Mm-hmm.
I think I'm still presenting.
Okay, but I can't see your screen.
Can you see me? Can you see my screen now?
Yes, no,
Can you see my screen now?
yes.
Okay. Dictionary and sets. So these are the four data structure that we're going to consider today. So what we're going to basically do is we're going to see why and when you should use any of this, because all of them are quite important depending on the context you're using them. So starting with list, what are lists? Can anyone from experience maybe give me what he or she understands by lists?
So firstly, I know that a list is in square brackets, so
Okay.
it can be whatever you want, I guess. So maybe you can list, I don't know, type of foods, and then it's in those square brackets in quotation marks.
Okay. Another person? We have square brackets. Very correct.
Oh, a list is an element containing different types of values.
Okay. Correct. Okay. For me, I'll say a list, like she said, contains the files, right? Okay. So for me, I'll say a list contains ordered items and it's mutable. So what I mean by ordered items and mutability. Yep. And just for you to know what I'm doing here, these are called markdown. Like you can see up there, this is markdown. We have codes. So this is just for me to. These are not codes. These are just short explanations. So they are not codes that are running. So what I mean by um ordered items? So someone should give me a list of possible values that we can have. Okay, let's say list of food, right?
Mm.
Okay. Give me some food, your best food I actually eat. Let's build up a list. Mine is bread. Who's going next?
Mine is chickpeas.
Chick
Chickpeas.
chickpeas. Okay.
Yeah.
Okay. Think I have to try that. I've never seen it before. Next.
Nigerian jollof.
You said? I didn't hear you.
I said jollof rice.
Oh, jollof rice. Okay. So this is a list of food that we just built. So when I say ordered now, it means that no matter how, anytime I print this, it's going to follow the order in which I actually entered these values. For example, bread is always going to come first, chicken is always going to come second, jollof rice so is always going to come third. So when you're working with data that you actually want to keep order, like you want to know the first value that came in, the last value that came in, list is actually an amazing data structure to work with. And mutability comes in the fact that you can change these values. For example, I know I mentioned index, Python index, and she made mention that it starts from 0. So for example, if I have a list of number, let's say XP 1, 2, 3. Okay, no. Let's use A, B, C, and let's stop at D. So the index of A, which actually means the position where A is in this list, is 0, because by rule, Python's rule, index starts as 0. So mutability comes in place. Mutability means the ability to change something. If something is mutable, it can change. So it means that we can change the values in the list. That's what it means. We can change the values in the list. Why would you want to change that? If, for example, now I say I don't like bread anymore. I like beans. I can, since bread is that the first index, I can do something like this. The first index should be equal to let's say I like beans now.
Sorry, I can't do that. You're not listening to the music app.
So I'm sorry, that's you. Shall just listen when I talk. So if we print our list now, we'll see that it has changed from bread to beans. And you see that to actually change the values in a list, that's when the mutability comes into place. The chicken pea is still here, the jollof rice is still here, but we have changed the value of bread. So let's imagine we want to change. Okay, permit me. Who mentioned chicken pea?
I did.
Okay, what's your, if you wanted to change it to another food, what will it be?
I guess carrots, I don't know.
Okay, let's say carrots. So what index is chicken pea?
1.
1, amazing. So do this, carrots. And if we print our food, wow, we have changed beans and carrots. Carrot. So this comes in place when you know that, for example, imagine you're building a chart system for your customers to know what they actually buy. So if you see maybe they change trend from buying chicken peas, carrots, you can actually effect that change in your database. So that's where list comes powerful. So beyond these two features that we have, list comes, each data structure in Python has what we call methods. Just like each data type also have structures. For example, if you take a string and say brain dot lower int, yeah, this is just changed all this into lowercase. If you do brain dot upper,
Can anybody see your screen? My screen hasn't changed. Can everyone
okay,
see your changes? Or is it just me? You can't.
okay, can everyone confirm that you actually see my screen? Yes,
Yeah, that's your screen.
probably it's network. Has it changed?
Yes, now it's fine.
Okay. So, like I said, different data types have different methods, which will come out with dots because the syntax actually the data structure dots the method. So we have something like this syntax.
Hi, Brain. Sorry to cut you short. Does
Okay.
anyone else think you should increase this font size if it's possible? Because
Oh, the front
I
side.
don't know, I can't. Yeah, it's really small for me.
Wow, 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 wow. Okay.
Can it be done? If not, don't bother. I'm just because of network, sometimes the pixels, the way they come in, is really slow, so they tend to be blocked at some
Yeah.
point.
How would I do that here?
Look into pressing Control and plus, maybe. For your screen to be bigger.
Yeah.
I don't know.
It's better now. Thank you. It's better.
Okay. Okay. So the syntax for initiating a method on a data structure is we have the data structure dot the method. So for lists now, what are the data its methods that are unique to a list? And just a quick advice: being a good programmer is not all about like how like cramming all the syntax or cramming how code should look. Yeah, you should know how it looks, but the most important thing is knowing what is possible because most times as a programmer, even people that have been programming for years, you always check things on Google, but you know what is possible. So like now we'll check the net and say Python list methods. This will take us to documentation. Okay, data structure. As you can you see my screen?
Yes.
Okay,
Yes,
you
fine.
can see And you can see there are so many list methods. We have append, extend, insert, remove, pop, clear, index, count, sort, reverse, and copy. So let's try out each of them. So we have dot append, add an item to the end of the list. Let's see how it works. Okay, let's get now from our list of food, we got our values from 3 users, right? So imagine we have a fourth user that comes to our supermarket and we want to add that person's best food. What we can do is to actually, one, rebuild the list, something like this, and add something like this and add the new food, right? Right? And this will work. Let's call this 2. Let's call this 2. So that if we print list of food 2, we have the new food entered. But imagine we keep having more users, which is the goal of any business, and we keep on doing this entry. We keep rewriting our code and adding at the end, which doesn't make a lot of sense because it's going to get tedious as time goes on. That's why we have this append. So what we could have done to make things quite shorter, just like the Zen of Python said, simplicity is better than complex. So what we would have done is to use list of food dot append and put in the new food, such that if we print new food, can we see? We have the new food appended at the end. So which one do you think is quite easy and quick to do? This one that we had to rewrite, or this one that we had to use the list method append? I want to hear your thoughts.
The second method when you use append.
Okay.
The append method is faster.
Okay. So that's why Python is quite easy, because the developers are always trying to make things easy. So the next we have is extend. And I can see here, it takes in an iterable, it extends this by attending all the items in an iterable. What's an iterable? An iterable, from its meaning, is something that you can iterate, like you can loop through. I don't know if you guys are familiar with looping, control flow, like something that you can go through. For example, a string is iterable. Okay. Who hasn't spoken here since this meeting started? I've been hearing only 2 voices. So, Miriam, permit me to use your name. Okay. So let's say for character in Miriam, print character. Okay. Since we're talking about error handling, this now we have an error, which is not a bad thing. It said syntax error, mixing parentheses to encode to print. Did you mean print character? I think it's giving me hint that I missed parentheses when I was using print. So when you get errors, don't just say, I made mistakes. It's actually going to guide you to make your codes better. So if you run this, voila, see it printed each item from Miriam. So this simply shows that Miriam is iterable because we can go each individual element. So if you want to use extend, so all we have to do, for example, now we have a list of books in our shop. Let's say we are still selling books. List of books. Let's say the power of focus. Someone should give me an example of book.
The 5 a.m. Club.
The Father.
5 a.m. Club.
5 a.m. Club. Another one. The Richest Man in Babylon. Richest Man in Babylon. So this is another list, which is an iterable, because we can go through each item. For example, if we say for book in list of books, print book, you can see it's an iterable. So let's imagine we want to join our list of books and our list of food to a list of all the things we have in our shop. Rather than creating a list and copying the list of food and copying the list of books into a new list, which will be quite taxing, we can use the extend. So we can say this list of everything is equals to. So we're trying to append this list of books to the list of food. So we can say list of food dot extend, and it takes in an iterable. So put in the list of books, which is an iterable. If we should print list of everything, okay, said none. Why is this? Okay, I think this does this in place. So what we could do is do this. Okay, let's see. List of food. Okay, so I'm saying did it in place. Let's refresh. It did it in place. So if we should run a list of food, a list of food, and do this and print list of food. As you can see now, we have a list of everything in list of food because we just extended the list of food with the list of the books. Do you guys understand?
Yes, we do.
Okay.
Or yes, I do rather.
Okay, please let's try and make it interactive. If you don't understand anything, just explain. If you don't like the example we used, we can use something else. So that's extend, just like trying to extend the list with an iterable. So we have insert. Set inserts an item in a
I have
given
a quick
position.
question.
Okay.
What's the difference between a list and range? I know,
Okay.
yeah, before you move to
Okay.
sets.
Let's do this. So a range is a Python built-in function. Just like when we have, I don't know if Said talked to you guys about functions. When you're building a function, something like this, let's say a function that adds two numbers, you put in the parameters, the arguments, let's say A and B, like this, and we'll do return A plus B. So when we are calling the function, we'll do something like this. Give me two values, say 5 and 7. We have something like this. So Python has built-in functions that they have already created like this, something like tf.range, put in your arguments, like they already have the arguments. In this case, A and B, and the backup codes for it. So whenever you call range, it works like this add. You put in your parameters that you want to work with. So range is a Python built-in function that gives numeric values between the two arguments you give. You don't need to write your own range function if you're working with Python. They are already built-in function, just like print. Print is a built-in function that has been written by the developers, something like you put in your text and the code to print it, to print stuff like this. I don't know if you get me. So range is a Python built-in function. Python function. Why a list is a data structure. So for example, if you want to have a list from 1 to 10, you can do something like list 10 and start doing something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is okay. But you can also use the range function to do this. It's a function. So you can do something like list of range. And whenever you're using Python on Anaconda and you have a function, a built-in function, or an object that you don't know what it contains, you can press Shift Tab. That's how I brought out this stuff. I just went into range and pressed Shift Tab. So it brought out the documentation. it says it takes an argument start, takes an argument stop, and a third possible one for this step. So we want to start at 1 and stop at 10. But we stopping at 10 does not include 10. We're just like you're getting to 10 and stop. So if you want to replicate the list 10 above, what we'll do is we'll stop at 11. So if we print out list 10, you see we have 1 to 10. If we print the second list of 10, 2, we have this. So this is quite easy, because imagine now I want to have a list from 1 to 100. If you're hand coding it, we write 11, 12, 13 down to 100, which is quite demanding. But with the range function, all we need is to say, okay, we want to get to 100. We'll do list of 1 to 100. And if we print this, if we should print this now, hey. So it's a function that helps us achieve certain things, like have a value within a range. So also, if you could look at the documentation, you see a step. So let's imagine we want to go 1 to 100, moving 2 steps each, like we'll go from 1 down to 3, 5, and all. So we'll do, let's just print list of range 1 to 101, moving at step 2. Can you see? We have 1.
I don't.
So we have 1, 3, 5, 7, and so on down to 99. So do you understand the difference now?
Yes, I do. Thank you.
Okay. So
Brian,
yeah.
quick question. How does Python differentiate the difference between the mathematical range, like working out what a range is between two numbers, and then the one you just showed, which is like a built-in function?
Okay. This range, like okay, let's see. Let's check. Think maths, Python maths, Python maths module range. A function like that. Okay. The goal of where's the notebook? Okay. Like you said, a mathematical function. If you say the range between 10 and 5 is like 10 minus 5, right? Right? Hello?
Yes,
Can you hear
yes,
me?
yes, yes.
Yeah. So that's like the mathematical way to go about it. But this is quite easy if we want to replicate that, because we know range gives us the maximum number and the minimum number. So for example, if we want to mathematically find the range between 10 and 5, we can do something like this. Okay, let's create a list. Let's call it Z. and create a list of 5 to 11 of range 5 to 11. So that if we print Z, we have 5, 6, 6, 7, 8, 9, 10. So we can mathematically do that with saying 5 is the first index and 10 is the last index. So mathematically, the range in which you want is answer will be equals to Z being the least. We're taking the last index and subtracting from the first index. And if print our answer, sorry, we start at index 0. I did 1, so it took 6. So we have to do index 0. So if we do our answer, we have 5. So in short, we can just create a function and say max range is going to take 2 parameters, x and b. Let's say x being the starting and y being the ending, like this. Create a list of values, create a list of values in the range of x and y. That creates the list, and we should return the list of values last index subtracted from first index. So with this our max function, we can find the max range between 100, 50, which is the starting, and 100, which is 49, because the list is going to create from 50 to 99. Like what I told you, it gets to the value but does not include it. So if we do 101, we get that. So you can see how we can manipulate the mathematical range from the Python range. Is that clear?
Yes, it is. Thank you, Brian.
Okay. So there are different um, stuff that we're going to do, but just for time, I'll just run through pop, sort, and insert, so we can move on to other ones. Maybe you can try the other ones. So, for example, our list that we have here, list of food. These are our list. Bread is at 0 index. Chicken pie is at 1 index. Jollof rice is at 1 index. And power of focus is at 4 index, and so. So imagine you want to insert a food. It's not making sense to insert a food after the richest man in Babylon, because if you do append, it's going to insert the food now below the richest man in Babylon. But want to insert it below jollof rice. That's where insert comes into play. So we'll do list of food dot insert. It takes in 2 arguments. Like I told you, do shift tab. You see, it takes index and object. So we want to insert it as index 4, 0, 1, 2, 3. Sorry, index 3, which is below jollof rice. So say 3, and we say fried chicken. Now, if you print list of food, we have bread, chicken, jollof rice, fried rice. I see you went to index 3. So that's another useful method that we can use in Python. This our example is making me hungry. I'm seeing a lot of fried rice, fried chicken, jollof rice. I'm hungry right now. So pop, like I said, removes the item at the given position. So if you should do list of food dot pop. Now we want to remove 5 a.m. club from our list. We check the index 1, 0, 1, 2, 3, 4, 5, and put the index. Popped it out. So if you should print five a.m. club is no more on our list. That's removed it. Also, another useful method is sort. So imagine you want to sort this list. This can be done by list of 4 dot sort. Right. Yeah. As you can see, nope. Okay. Let me print it out. Okay. Let's see what list of food has. Bread, chicken jollof rice, and fried rice. Okay. Let's see what the commission say. So the item to list, please. Okay. Okay. Let's start that again. So let's run this. So Excel list is an error. List of is not defined with the inputs initially. Well, okay. It said attribute error, non-type object has no attribute sort because when I overwrote the list function, the list. So I'm trying to rerun it, overwrote it. Okay. There it is here. Yes.
Your screen.
Yeah.
Your screen. We
You
can't
can see
see
my
it.
screen.
Yep.
Wow. It's still up.
Yeah, it's
Can you see
not.
it
I
now?
think it's network. Yes, it's here. Yeah.
Okay. Okay. If you can see, it has sorted the list. I overwrote it. That's why I was having this error. As you can see, we have 5 a.m. club because basically from Python syntax, numbers come before alphabets. So 5 came here first. Then we have bread, chicken, jollof rice, the power of focus, the richest man, and all. So you can play around all this, and don't be scared when you get errors. Errors are part of coding. So you read the errors, try to understand what they're trying to say. So I think we should move to tuples, which is another data type. So, okay. Any questions so far? Any questions so far?
No, not from my side.
Okay. Okay.
No, not on my
So,
end.
tuples are still like lists. They are ordered, but they are not mutable. Hello?
Did you please repeat that?
I said tuples are
You said
like
couples are
lists,
what?
but they are ordered, but they are not mutable. So let me give you an example. For example, why it is important? For example, imagine you're working at Facebook and you save people's PIN, like password. Let's say we have 5199 password, and to a list is figuratively denoted with brackets. So let's say we have different pins, 999, and okay, this should be numbers. Let's see that's numbers. Numbers. And we have 364. Now, we don't, by right, we don't want maybe when we are working our codes, we are working, changing things, just like we're trying to solve problems, we change passwords. If you print out passwords now, it's ordered, but we cannot do something like this, 0, 0 equals to 7774. Are you seeing just the way we did list, this for list, you get by the index. We can't do that here because it does not support that mutability. We can print this. This is going to give us the first index. We can print it. We can look through it, but we can't change it. If we say for password, let's say for let's just call it P for PD in password print PD. It's going to print out. So you should that is an iterable, but we can't change it, the values. Another built-in Python function, just like range, is length. To check the length of the tuple, check of the list. If we do this now, password, we're going to show that the length is 3, since it contains 3 passwords. If we should try it on our food, length of food, we have 8. Since we have 1, 2, 3, down to 8. So that's another built-in Python function. So tuples also have their own methods. So just like I don't know all of them, we still go to Python, we still go to Google and say Python tuple methods. Let's go to documentation. Tuples list. Tuples. Okay. 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 Still trying to see the documentation, Python documentation for possible methods. Okay, let's the documentation is not actually showing those methods just as we did for list. But I think some Python some list stuff should still work. So let's try password append. Okay. So tuples doesn't have a lot of methods just like list. They have just two. They just have counts and index. Can you see my screen?
I can't see what
Hello?
you're typing anymore.
Hello?
Okay, now
Let's
it's
say we
fine.
have another password here. Three, let's say we have 5199 again or something. So if we say password dot count, it takes a value. So let's say maybe you want to check if a user has already like a password that's already in the system, because most times some system check if someone is working with a username or a password or something like that. So let's check if we have how many times we have 5199 in our tuple. We can see we printed 2 times. So it's showing us that we have 5199 twice. Can you hear me?
Yes, we can.
Okay.
Oh, I
So
can.
also we have to also get the index. So for example, we have password dot index, and let's say we print out let's say we want to check the index of 9999. It tells us that at index 1, that's 0, 1. So those are some useful methods in tuples. So it's iterable, but it cannot change you cannot change a value once you've already initiated it. Do you have any questions here? So one other useful thing that we can do with tuples and also lists is what we call unpacking. So unpacking. So for example, we have a list, the password. We have a list. I want to create a variable from those lists. We know that we have 4 variables. So if we want to create maybe A is equals to this, B is equals to this, C is equals to this, and this equals to this, we can do it like this: A, comma B, comma C, comma D equals to password. So that if you print A, can you hear me? We have 511. If you print B, hello, can you hear me?
Yeah, we can hear you. We can hear you.
Okay, so that if you print B, you have this, and so on. If you print C, you get that. So this can also be done with list. Like if you go back to our list of food, if you do A, comma B, comma C, D, E, F, G, H equals to list of food. This also works. We do print A, we have 5 a.m. club, print B, we have bread, and so on. Also, for example, maybe if you just want to create a variable from the first two, maybe from this password, you just want to create A and B, maybe put others for the rest. So that's where we have what we call keyword args and keyword arguments. So we can do it like this: A, comma B, comma asterisk others equals to password. So that if we print A, we have that. If we print B, we have this. And if we print others, we have the other password here. So I think that's some useful thing that we can do with list and Python. There are others I can see check about, but tuples just have 2 methods: the count and index. Because they don't want you to change the values in the tuples, just like the way we did in list. So for example, you're working with data that you know that you don't want any manipulation to come from either the developer, because most times when you work with your code, you share your code, you don't want your codes to be edited, so you can use tuples because you can't change them. Okay, so the next that we'll have, okay, before I go that, let's talk about sets. Sets. Let's talk about sets. So sets have they are denoted with curly braces. For example, set takes unique values. So for example, we have a set set 1, let's call it set 1, equals to 1, 2, 3, 4, 4, 2, 5, 6, 6, 7, 9, 9, 0. Yeah, a set is an unordered. Can you guys hear me? Can't hear anyone.
Yes, we can hear you.
Okay, that is an unordered collection of data. So if we should run this and print out set 1, as you can see, the set 1 printed only the unique values. So we can look here, we have 4, we have duplicates of 4, duplicate of 6, and duplicate of 9, but the set created only the unique values. So we have 0, 1, 2, 3, 4, 5, 6, 7, and 9. That were the only unique values in the set. So, for example, you are working in a project that you only need unique values from a value. For example, if people are computing values of maybe X, or names. Okay, for example, you're playing a game, and anytime a player plays, he puts in his name and all that. But you want to know, despite how many times the game is being played, you want to know the unique players in the game. You can use a set to get all the play time and just like for you to extract the unique player names from the data. So that's where set comes in handy. They have amazing methods. If you go to the documentation, they have some amazing structures that work with Venn diagrams majorly. So if you're working with Venn diagrams, that's when we could understand this. They have things like union, subsets. Let me just give you an example. So we have my sets. Let's say set
Sorry,
1.
Brian.
Okay,
Let me just
already
ask
have
you a
set
quick
1.
question
Huh?
before you continue. I said, let me just
I
ask
can't
you
hear
a quick
you.
question. Can you hear me? Hello? Hello?
Hello? Can you hear me now? Okay, I can hear you now. Sorry about that. I think it was network. So what were you asking?
Okay, I was saying, if I'm to understand orders or ordered, should I call them ordered variables or ordered under the Python context, it basically means
Okay.
in the sequences at which or at the time at which um each item was imputed into like a list or a set, right? Or maybe let me use a list.
Yes.
So it means as the way it was imputed, it brings if you have to print like a function, a variable for a list, right? If you have to print that variable, to
Yes.
bring out it will for a list, it will bring out or it would return like the way you imputed them into the system.
Yes.
Okay. So that's why for set
I,
it's
I knew.
unordered.
Yeah, you see, like for example, our sets. We imagine we started with two. Okay, look at our set. We started with 1, 2, 3, but when you printed it out, you printed with 0, 1, 2, 3. You get, so it's on order
Yeah.
because the order when we inputted data was from 1, 2, 3, 3. but you didn't keep that order.
Yeah.
Okay.
So,
So
but the
like I
difference
said,
is like I think for set it probably arranges it in an ascending order, right?
yeah, kind of, but not like an assignment. It's just like taking the unique values. Just taking the unique
Yeah.
values.
Yeah. So it doesn't replicate values the way it's replicated in the set content.
Yes.
Uh,
Okay. So like I said, there's some amazing methods that they have. For example, we have set one. Let's create set two. Let's create set two. Let's just create a set of even numbers. Let's create a set of even numbers: 2, 2, 4, 6, 8, 10. Let's just do a quick one. So if we should print set two, we're going to have 2, 4, 6, 8, 10. You remove the duplicates. So here we have things like union, difference, is subset, just like your Venn diagram. Since I don't have a Venn diagram, I wouldn't go too deep into it, but I know if you can recall, if we do set one from Venn diagram knowledge, set one union set two, what is going to happen? What do you think
you
is going to
probably
happen?
print out, you probably join the two sets together and print out all the content of the two sets without repeating the numbers.
Okay, let's see. Let's test your theory. Yeah, that's what he did. So set two
So
is
just like
here.
the Venn diagram thing we're talking about.
Yeah, so they have so many. We have things like subsets. So this is only if you're working with Venn diagrams, they have things like subsets, sub is subset. I think is subset. Yeah, is subset this. So this is not is set one. It's not a subset of set two. So it's going to give us a true value. It's still false. So imagine we had a set of something like one. Let's create set three. We have something like 1, 2, 3. So set 3 now by right is a subset of set 1. So if we should run this with 3 and 1, this should give us true. So these are just some amazing. We can do intersection. Okay, let's just try intersection. There are others that you can just um look at, but these are good when you're working with Venn diagrams in maths. Okay, so let's say it's set one dot intersection set two, right? Intersection, 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 intersection set three. So if we should run this, so you can see between set three, set three and set one. Okay, now I'm supposed to do set two. Sorry. So between set two and set one, intersects are what are common. That's what intersect just means. We have 2, 4, 6. So those are the common things between the two sets. So you can play around this. That's majorly some methods. We have things like difference and all. So there are some amazing these methods with this when you're working with set. I think these are the general ones that at least that we can still remember how they work from maths class. So next we'll go into dictionaries. Going to dictionaries. I hope everyone is following. everyone is feeling.
Yeah.
Not too
Yes,
far.
Brian.
Okay. So dictionaries are quite similar to dictionaries as they have coily brackets too. But a dictionary has what we call a key pair value or key value pair. Sorry. So we have a key and we have a value for it. So which can also be noted as KV. So we have a key and a value for it. So um so if you want to create a dictionary, you can say effects dictionary. So um let's just build okay, what's a dictionary? I think that's what we have been working, what we explain each individual component. We try to define it. Can someone just quickly explain what she or she understands by dictionary? Okay, so I would say a dictionary is a collection in which we're trying to build a container, like a collection of data in which each data point has a unique value. So rather than using index like we used to get values, we use that unique value. So it's not ordered, it's not ordered, it's mutable. It's mutable. You can change values, but it doesn't work with index. Like we can index value too, but we can extract values via the key. So just like we have a key, and each key is unique to the value it has. So a quick example. Let's just have one. So let's say we're going to build a dictionary with a name, and what will we have here now? A name and passion or hobby. Can you guys hear me? So
Yes, we can.
so let's build our fake dictionary with our name and hobby. So okay, so let's start class dictionary. So let's build our dictionary. So I'll start with my name, which is unique to me, Brain, and I love photography. So who's going up next? Let's just populate our dictionary. Who's going next?
I'll go, Brian. It's Nokolo,
Okay.
spelled X Noxolo.
Okay.
Then reading.
Reading, amazing. Who's going next?
Yeah,
Okay. You got it right. Okay, Miriam.
your screen,
What
your
do you love
screen,
doing?
your screen. Bike.
Oh, is it back?
Yeah, it's back now.
What do you, okay, what do you love doing?
Biking. I like right. I love biking.
Amazing. And lastly,
Tokolo.
we have it. Kolo. What do you love doing?
Music, listening to music.
Okay, music. So we have our class dictionary. So let's print it out. Let's see what it looks like. So as you can see, we have built our dictionary. So we can't do class dictionary and index. like you see, it says it gives on an error, key error. We can't do this in Python. We can't do this in dictionary. We can't use index to get values, but instead we use the key. So, for example, I want to get brains details from dictionary. I'll just put in the key, which is his name in this case. Since we work with, if you can look at the syntax, we have key and value. So brain is the key, photography is the value. So if we do this, so it brings out photography. So imagine when we have a lot of individuals, like we have our classmates and our hobbies and so on. We can actually just get their what's it called, their details from just their name. And this can also be improved on. If you can imagine, maybe I had multiple hobbies, I can put it in a list and say photography. What else I love doing? I love playing chess. What else? I like cooking and eating. I'm a foodie. I like eating. What else? There's gaming. Let's see, gaming. Gaming. Say gaming. So with this now, it will still work. Press out the classic dictionary. I'm still working. So if I want to get all the hobbies that Brain does, I just put in his key, which is his name in this context, and voila, gets his hobbies. So you can imagine this, that maybe we have the company and we have the database of each person where the name stands as the key. So we can have things from their phone number. We can input numbers here. We can put numbers. Let's say my phone number is 1234567, and it will still work. So if I want to get Brain's details, I can get his number. So this is quite easy to arrange information, multiple information about a unique identity, which in this case is our names. So is it clear? Do you have any questions surrounding it before we delve more?
I have a question, Brian.
Okay.
Since dictionaries have two inputs, which is like the key and the value,
Yeah.
are they possible to append
Yeah.
or not?
Yes. We're getting there. It has its own method, just like lists, tuples, and sets. Each data structure has its own method. We're getting there. So it's actually iterable. It's iterable. For example, let's do class dict. Let's use one of its method, items. This is going to give us. It's going to give us the items, the name, and the person. So, for example, we want to loop through this. What we'll do for key. Since each entity has a key and a value, so we'll do for key and value in class dictionary dot items, because we have to print this to get the dictionary items. So we can say print only the keys. So what do you think is going to be printed out? So if we do print only the keys, we're going to get only the names. If we do print only the values, we're going to get only the values. So we can just like we can make this interactive. We can say print using f string. We say put a placeholder. We put in the key, which is the name. Loves the following, and we put in the value. So that if we run this now, we see Brain loves the following: photography, chess, eating, gaming. Nozolo loves the following: reading. Miriam loves the following: writing. Kolo loves the following: music. So we can actually iterate through it. So this is quite quite interesting. It's an amazing data structure. If you can understand it, you can harness the power, and it's quite easy, because if you're trying to replicate stuffs like this, you have to use maybe list of lists, and as the complexity increases, it's going to increase. So even here now, I can have another list again. I can have another list, maybe having the alphabets. It's going to still work. Having the alphabets, let's see, P, C, but all this is unique to just brain. It's ID. So if I should take this now, I still get this. So that's some amazing things about list. Dictionary, sorry, about dictionary. So let's see some of its methods. Mm, let's see some of its methods. Dictionaries. Okay. We have said can be modified using okay. This documentation is quite you have to read through to be able to pick them one by one, but a quick way to get the method of an object in Python, because everything in Python is an object. The data structure, maybe on another workshop, maybe we'll go into objects to understand them, but everything in Python is an object. To get the methods of this, we just simply do, for example, do the class dictionary dots, then press tab. We have all the methods rather than go to the documentation. But why we use the documentation is to quite understand what they actually do. So, like we see, we have clear, copy, get, we have get, and also we can just, like, we have used items. We use items above for loop. So okay, if we do dot let's do dot keys. Dot keys. Dot keys. If we do this, it's going to get us all the dictionary keys. If we do dot values, it's going to give us all the values. So these are just some of the methods that with the data structure. So we have the clear. If we do this, it's going to clear our dictionary. Maybe we'll do it at the end. But since we are still working with it, so we should still work. So when I say the Python the dictionaries are mutable. For example, if I want to change all my this thing now, my brains if I want to change brains what's it called? I want to change brains uh, hobby. Let's see if it's possible. So do brain, and we do equals to, let's say, jogging. I don't like jogging, but just an example. So let's see, print this out. As you can see, it's mutable. It has changed the value of my hobbies. Can you see that? Hello? Hello?
Yeah, we're here.
Okay, so you can actually change it, but just like tuples was immutable, couldn't change, but lists and dictionaries are mutable, can change. So so we can actually rewrite this is so which is quite good. For example, tomorrow the person says that he wants to change his name from the database. You can just he wants to change his phone number. Imagine you're working at the bank and we have the name of the person, which is the key in our case, and we have phone number. Maybe he comes and say that his phone was lost and he wants to change his number. So we can just use dictionary, get his name, and get his name and change his phone number. So which is quite interesting. So let's see some other amazing methods that they have here. So like pop item, like we've seen before, removes a random removes a stuff from the so look at the this thing. It says it takes in, removes key and value. So if I should put in brain one, like I said, now type error, pop item takes number of arguments, takes no argument one was given, so it does not take in anything. So if we do this pop item, it randomly popped out Tokolo's entry. So this pop item should be taking, it's not something that you quite use. Maybe if you're trying to do maybe a destructive programming that maybe you want to be removing a value, maybe through loop randomly. This one does it randomly because there's no logic why it removed them Tokolo's stuff from the list. So you have to be careful with that pop item because it randomly removes. Let's see, pop removes specified key. So if imagine now this one takes in specified key. So if I put in brain, it pops brain off the dictionary, so that if we check now, we just have 2 people left in the dictionary. So this is one you want to use. This one pop item just takes off a random value out of the list. So like you asked, if you wanted to add a dictionary, how do we, if you want to add an item to a dictionary, how do we do it? Here we have dot update. So how does update works? Key in E. So let's put back who did you remove? Okay, we removed the Tokolo's stuff. So let's say we put in Tokolo back, and her hobby was music, listening to music. Okay, expected one argument. So let's try to debug. Let's try to debug. Let's see what they wanted. So as a programmer, like I said, you just know what's possible. It's not like like how everything should work. That's why we debug. That's why we debug. We look at the errors, and see what they want, how we should go about it. Okay, so let's see. We have let's see how we can update. So let's see, we have a temporary dictionary. Okay, so since it works like list with mutable, we can actually do something like this. Let's see. We put in the what's it called, the key and the value, which was music. Let's see if it works. I think it did. Let's print out class dictionary. Yeah, it worked. So this update, from what they said, takes in a dictionary. Takes in a dictionary. So just like when we did extend, that we extended is an iterable. So in the list. So I think that's how the update works. So let's just create a temporary dictionary and just see technology dictionary. Let's see is equals to A is equals to 1, B is equals to 2, and let's just create this. So I think update takes in a temporary dictionary. Yeah. So if we do print, or let's just print it out, let's output it. So like I see, so the update works like extending list. You put in a list on each table, but here now we have to put in a dictionary. So if you want to create a new value, you just like list, you put in the key value as we did in cell 117, and it works. So I think I think that's one, like some quick methods that we can use. So you can just check the other ones. We have the copy, like the name sounds, to copy. So set defaults. You can just check some of them out. So if we should clear and print now, I think the dictionary will be empty. Yeah, it's empty. So those are some amazing features we can do with that. Is there any questions so far before we just diving briefly to the last course of the day, which is error handling? Error handling. Can everyone hear me? Is there any question? Did I do anything that was confusing? Miriam,
I'm okay.
Nozolo.
Everything is okay on my side.
Okay, everything is
I'm
clear.
also good on
Okay.
my side, Brian.
When are you going to send them?
I can't hear you. You said?
No, I'm saying everything is okay on my side.
Okay, so
I'm also good on my side, Brian.
okay.
When are you going to be sending us profile? Hello, can you
Am I
hear me?
supposed to? I can hear you.
Can you share this Python extension file on the Slack group for us, just for reference
Oh,
purpose?
okay. Maybe I'll mail it to everyone. Okay.
Yeah,
Then,
thank
okay,
you.
I'll do that. So error handling is just the ability, like we have seen a lot of errors. Like I made sure that okay, we had some errors too, so we can just see how it goes. Because when you're, for example, if we do 8 plus 2, oh, okay, we had A before. So let's imagine we had there's a value of A before. So let's say we have Q plus A. We're going to have name is not defined, which is a name error. Let's say we do 2 plus 2. We're going to have type error, can only concatenate string to string. So there are different errors. Just thinking of common ones that are okay, like when I did print 4, I had syntax error, and also there are different errors, and there, if you go to check types of errors on, there are so many. So error handling is your ability to handle these errors. Because, for example, if you build a project such like Facebook, and maybe once your users are trying to log in, they have error, definitely you start losing customers and your stock can stop reducing because of just that small error. Because for example, Twitter stock is going down because of the hack that happened to them. So when you're building a business, you don't want these errors to happen. So sometimes when you're building your business, you want to try to catch this error before they hit. So that's when we have things like try this, and let's say code. We have something like this, code, and we have except. So we have something like this. So this helps us to try our code, and except catches this error. So let's just see this. Let's just see this in practice. So let's say we're trying to create. Oh shit! I'll just make this. Yeah. So let's say we're trying to create what example I use. Okay, let's just create a simple function. We're trying to create a function that squares two numbers. Let's just call it square. That squares a number. This is squares a number. Squares. Okay. So it takes in the value that I want to square. So definitely we want the user to input the value. So we have a value x equals to input please enter a number. Please enter a number, right? And when person enters a number, the function should return x times x, right? So this is a simple function that squares two numbers. So if you run this, it works. So we call it, we say squares. Okay, no. Let's do this like this. Let's do this like this. Let's do it like this. Let's ask for the user. Let's ask for the input first from the user. Let's ask for the input. Okay. That's cool. So we should return, sorry. We should return value times value times value. Yeah, so that's what we want. So that if you put square dot 2, it gives us 4. If we do square dot 9, it gives us 81, and so just like we should return value times value. So what if now, for example, someone puts in A? What do you think is going to happen? What do you think is going to happen?
I'd say you're gonna get an error because A is not defined. Like the value of A is not defined.
Okay. Also, if we have something like this, which is correct, if we have something like this, what do you think is going to happen? We have a string A. Let's see if we should run it. We get type error cannot multiply sequence by a non-int of type. So we can't have a square. We can't have a square, like we cannot times from our function. We cannot do A times A. It's not making sense. So it has a type error. So if we want to make our function so robust that in case the individual or the users, and I can see our program has stopped working because of this error. So we can do this. We can improve on our function by using the try except. So how does it work? So we'll do something like this. We'll define our function. Let's do beta square. Let's call it beta square. We're just taking the value. So here now, instead of just running the code, we'll do try this. Try returning value value times value, then except you should try to catch a type error and print please enter a number. Let's see if this works. So if you should do beta square of 2, it works. Beta square of 9, it works. Let's try beta square of a string A. Are you seeing? It told us, please enter a number. So rather than bringing out this error, which imagine we had this on production, like a calculator that this thing, instead of bringing out these errors and plenty things that the individual will not understand, people start asking what is trace back, what is this, what is that. I'm tired of this system. So instead of that, now we can print telling the person enter a number. So the person should know that, oh, okay, I wasn't supposed to put a string, or okay, it's supposed to be a number. So this makes our this inquiry robust. And this, we can also improve on this, because enter a number. If you enter a number, this thing won't continue running. It's not working. It's not going to run. So what we can do is to put this in a while loop. So let's see if we can make this let's see if we can make this more interesting. So let's have the input of a user. Let's have this input of a user, and just if we should do this, okay, let me just do it. Let's say value is equals to input of user. Let's say enter a value. Enter value. Yeah. Let's see if we should do this. If we should run this, you tell us to enter a value. If you should put 2, it works. If we print value, we get a string of 2. So this input function saves the value as a string. If we should put type of value, we have a string. So what can we do here to improve this? So we can say this. Let's copy this. Since we want it to be numerical, we can put init to try to make it a numerical value. So if we should save this and we should put 2 and rerun this, we have an integer because that's what we want. So let's say we can enter this our model. Let's say our beta is our function. So let's copy this. Let's copy this. So let's copy this. Let's not put anything here. So let's put while true. Please, are you guys familiar with the while loop? So I'll know how I'm going to explain this. Are you guys familiar with the while loop? Okay.
Yeah.
Noxolo and Tokolo, are you guys familiar with it?
Yes, Brian.
Okay, cool. So while true,
Yes,
nice. This should keep running. So while true, we want to get the input of the user. So we'll copy this is our code here. Copy this our code. While true, we want to have the value of our user. So we're going to try this times this. Then we should catch type error in case the person puts a string and prints this. And also we should break, because if we don't break, this is going to be running forever. So we should break. No, we should break. We should break when the individual has put in the correct value. That makes more sense. We should break once the individual has put in the correct value. So let's give this a shot. Let's see. Beta square. Beta square. Let's run this. Enter a value. So let's say we put in 5, 4. It works and it breaks out because the correct value. So let's try putting a string. Let's see, we put in let's put some gibberish. Let's put some gibberish. Okay. It didn't catch our error. Why was that? Let's see. Beta square. Please print number. Wow, to try this. Break. Okay. Okay. It says beta square takes 0 original memory. We're not supposed to run this yet. We're supposed to run this, then put in the gibberish here. Yes, I was supposed to do so. It says this is another value error. It says value return for int with base 10. So this was not a string because we didn't put the quotation mark. So this is like a value error. So these are different errors that we have. So we'll still catch this. But for now, let's just run this the way we ran it before. So beta square. So let's put in a string in this our case, because we didn't put a string that time. Let's put in a. Okay. So now it's still telling us invalid literal string with base 10 that it cannot take this, because do you know why? Because if you look at our code here, we did after we did the while loop, we converted the value that we had here to an int. So what this code is trying to do now, we are getting the value a. A cannot be converted to a string, so it's canceling out already. I don't know if you see this. It's already canceling out already. So let's see how we can do this. It's already canceling out because int of a is just like, okay, let's look at this now. If we should do this, see this error we're having here. Let's do this. Let's do int of a. Oh, there's a value a already. Let's have int of q. As you can see, q is not defined. And if we should do int of q like a string, we're having value error. Like you see, the errors are the same. Invalid literal for int with base 10, the same error. So this is just like we are putting the value of a string. It's trying to get the integer of that value and giving out the error. So you can see how error messages gives us more knowledge about our program. So let's improve on this. So what do you think we can do? I want to hear your thought. Let's debug together. What do you think you can do? What are your thoughts? So we can make the value try value dot value equals to init dot value except. Now in this our case, we're having a value error, so we can do except a value error. Print, please enter a number. So try this. If this doesn't work, okay, let's see. Let's enter a value. We enter 4. We have 16. Let's do this. We enter a string. Yeah, can you see? Now it's telling us, please enter a number. So let's enter another gibberish. Put S. Please enter a number, enter a value. We'll still do this until this will keep looping like this until we enter a valid number. Put in, let's say we put in a string of 3s. Please enter a value until we say, okay, we've understood the mistake. I will put in 4. The program breaks. Do you guys understand? So these are just like the ways that we see from our errors. We understand our code and we see how we can manipulate to better understand errors and how to handle them. Like we saw, we're looking out for this one to so that okay, it was a value error I was giving out, and also can also make this much better. Can do something like this, just to be more intuitive about our program. We can do something like this. Please enter a number. Before we do please enter a number, we can print out the error message that the person is having. So what we'll do accept value as error, then print out error. So this is another better one. So if we do this and copy this, put this here, run this, please enter a number, we put in 4, it works. Let's try that again with it is string. So if we should run this with a string, let's say we put in A, So it tells us that it puts out this error that we had here. This where is it? This invalid retrial for int with base 10. Instead of breaking out of the program, it prints it as an error. It's invalid retrial. You can see enter a value of it. It said invalid retrial with base 10 A. Please enter a value. So the program it keeps running, but it doesn't break out like this. So we can see appeal the error, but it doesn't break out. So our programs keep running. So even if we keep putting a string, a lot of string, sort of, it keeps printing out the error, but the program still works. So rather than breaking out, it works. So once you put in maybe 10, it breaks out to 100. So that's one way we can handle errors. We can also have multiple. We can also have multiple errors. Like we can have something like catching different errors. We can catch different errors. We can do something like this. Except this, comma name error, comma type error. So we're like anticipating possible mistakes that users may do. So we're anticipating different mistakes that users might do. So this just makes our program more robust. So if we should do maybe let's say create something like this. This one has a name error. Okay. Let's see, did I run this? Okay, it's telling our printer and this stuff. Okay. Okay. So are you saying it caught the error by right? This does not have a logical meaning. This asterisk like star cannot square star. So it's catching the error and making our program run. You get, so just like we're trying to see star dot star program is still running here. It's still running here. So it's running. So it was supposed to enter a value 4. Okay, 3. So like you see, this is syntax error. So we have already caught it because from our program, what it's trying to do init of star, using init of star, which is not possible. So we've already caught it. So this is like a way to handle errors. We can use the try except to make sure that our program keeps running, because when we are pushing to production, because definitely the end goal is to use our products as Python, whether it's web development, we are going to find machine learning, data science from here. You see that you're able to catch errors because your users might put in something they're not supposed to put. So those are just like a quick way to catch errors. So you can also read about that, but I just want to give you an introduction so you can actually make your programs more robust. Okay, and any questions? questions? Hello? Hello?
Hi. I think I'm okay with it, and I just have to go through the error handling, and then maybe if I have a question, I'll post it on the Slack thing.
Okay. Miriam and Zulu, do you have any questions?
No questions from my side, Brian. Thanks.
Okay. Okay. So it was nice having you guys here. So probably I'll share the stuff to your mails. So if you have any more questions, maybe you can reach out to me. So thanks for being here. I think that's bye from me.
Right. Thank you. Bye.
Thank you.